So the presence of groundwater in rock slope can have a detrimental effect upon stability for the following reasons. Because of the water pressure, the changes in the water content. So water pressure reduces the stability of slopes by diminishing the shear strength of potential failure surfaces. And that is why if you consider the keel, they were looking at water and then stress reduction factor. So if you have water present in any phase, this is its end result. The pressure there could reduce. Hello, go ahead.
I was mentioning that that particular example is not in the handouts.
Yes. Initially, I didn't want to do any calculation, just teach the concept and go. But then I later realized the understanding will be better if there is this. So I can share that example with you when I'm sending the material. Yeah.
Okay, thank you.
Mm-hmm. Then we have changes in moisture content. So of some rocks, particularly shales, can cause accelerated weathering and a decrease in shear strength. So if I have so much water, the water content within a given rock is too much, then it may result in accelerated weathering. The weathering rate increases. And so it means if you happen to check the durability of such rock, you wouldn't get good results. The durability through the slick durability test we did yesterday, you will get lower values when you have rocks like shales to deal with. Then freezing of ground can cause wedging. So wedging is a situation where you have, let's say you have a slope. That's my pen. You have a slope and you have a particular failure, or okay, let's say discontinuity, meeting or intersecting another discontinuity in a slope like this. So because of that discontinuity intersection, this section will fall off or slide out, and that kind of failure, we call it wedge failure, and it happens in slopes a lot. So when I have freezing of ground, it can also cause this in-field fissures due to temperature-dependent volume changes in the ice. Also, freezing of surface water on slopes can block drainage paths, resulting in a buildup of water pressure in the slope with subsequent decrease in stability. Erosion, and then again excavation costs, because if you are dealing with a situation where there's so much water, this water can cause more harm in terms of your explosives you are going to use there. Water resistance, if you have a non-water resistance AMFO, assuming you bought that in stock for your operations and then all of a sudden there's water coming out, you would have to spend more money, leave this stock there and look for one that is water resistance, and it leads to cost. So by far the most important effects of groundwater in a rock mass is the reduction in stability resulting from water pressures within the discontinuities. Various methods exist for including these water pressures in stability calculations and designing your drainage system. So in examining rock or soil slope, it may be a mistake to assume that groundwater is not present if no seepage appears on the surface. Yes, you are likely to be deceived if you are considering slopes and you don't see water, but then maybe it may be hidden in there because it doesn't flow as normal water. It seeps. So the seepage rate may be lower than the evaporation rate. That is, if you are in zones that you don't have so much sun, as in the case of Takwa, where there is rains all the time. So if the evaporation rate is lower than the rate at which there is seepage, then you have to consider other mechanical means of handling the water to avoid failure. It is water pressure and not rate of flow, so which is responsible for instability in slopes. And it is essential that measurement or calculation of this water pressure forms part of site investigation. So if you want to, so we are talking about the pressure head, where we talked about the water pressure over the unit weight of water. This thing we made mention of. So if you are considering any activity in slopes, there is that need for you to compute the water pressure, measure to see at what pressure the water dashes out within the soil sample. What is the pressure that exists in the rock or the soil in terms of water? If you get to know them, it can influence your decision. So drainage is one of the most effective and economical means available for improving the stability of rocks, where you try to dig. Sometimes we come up with holes. It's here. So we try to dig wells along the pits or around the pits and try to pump the water out, or we come up with sumps to pump the water out. And we can also determine the coefficient of permeability if we are using these wells, assuming I did 2 different wells close to each other, and I want to measure, because in the lab, we are able to mimic the situation such that we can do this change in height or elevations of the water. But then in the field, we do that by drilling wells that could help us measure the water levels and use that to compute for our K. So, and that formula is proven. So it says that equation 23 can be rearranged to show the volume of water Q flowing through the sample shown in figure 18 and a specified head as follows. So if you happen to know this computation, you can get your K. Once K is gotten, you can calculate for the rate of the quantity of flow at a given length. And then the next topic would be slope stability or rock slope stability. And we are not doing that today. We will consider that the next time we meet, which